When we picture a high-stakes heist, we usually imagine a scenario relying on lucky breaks, high-speed escapes, and frantic improvisation. We expect to see chaos barely held together by desperate decisions. But professional execution requires the exact opposite. It is the exhaustive elimination of the need to improvise. Flawless operators aren't out to break the rules. They map a system's internal logic so thoroughly that they can force reality to bend strictly to their calculated parameters. Take this facility, the Pendleton Pike Regional Node. It operates as a modern financial fortress, built entirely on overlapping layers of defense. If any physical or digital anomaly is detected, the primary security grid engages an automated lockdown. In a matter of seconds, the entire building turns into a sealed steel tomb. You do not overpower a system this tightly wound. Instead, you spend months mapping its internal clock to weaponize its absolute reliance on predictable, automated routines. You use the building's own rules against it. This diagram tracks the human guard. After 6 months, operators isolated a pattern. At 2:05 a.m., the guard takes an 8-minute smoke break. While physically separated, operators connect a frequency scrambler to the maintenance port, executing a 10-second digital handshake. This bypass feeds the necessary authorization codes directly into the network, preventing a precinct-level silent alarm from triggering before the door latch even opens. The human element is defeated without force. By mapping the guard's rigid schedule, the operators move completely outside of his awareness. Once inside, human habits give way to a digital metronome. The operator's movements are now dictated entirely by the building's 24-hour power flow and its internal clock. At exactly 2:15 a.m., the primary grid drops its encryption layer for exactly 180 seconds to sync with the central treasury. This power reset creates a physical deadline. The intruders have a strict 60-second sprint to cross the dark corridors before the pressure plates arm themselves. The final mechanical obstacle waits at the vault. This cross-section shows massive automated deadbolts that begin their locking cycle the very moment the primary power drops. If an intruder sends a stop command, the software immediately flags the anomaly and hard locks the facility. Instead, they let the machine run. The system pauses for 2 seconds to verify integrity. During that micro-window, operators inject a spoofed code, forcing the bolts back. Hijacking a highly secure automated network means letting the machine execute its own protocols and slipping through the verification process at its most vulnerable microsecond. With the seal broken, a new timer starts. The team has exactly 90 seconds inside the freezing vault before the auxiliary power restores and alerts the city. In a room holding millions, greed becomes its own security measure. Lower shelves hide tracker traps. Extra weight compromises escape velocity. Efficiency requires strict material discipline. They focus on center stack currency, capping bags at exactly 40 pounds. Surviving the vault requires a psychological discipline that prioritizes the mathematical certainty of the exit plan over maximizing the total haul. Exiting the building introduces an unscripted external threat, a city police cruiser sweeping the alleyway during a severe thunderstorm. The officer isn't responding to a triggered alarm. This is simply a routine sweep by a driver looking for shelter from the torrential downpour. But this topographical map shows the preemptive solution. The sector's outdated 1992 infrastructure guarantees a severe drainage failure during heavy rain, creating a 6-inch deep flood pool that blocks vehicle access. Knowing this geographical variable forces the cruiser to abandon the sweep to avoid bottoming out. Meticulous environmental research turns an unpredictable hazard into a strategic advantage. The operators merge their vehicles seamlessly into late-night traffic, becoming completely indistinguishable from the background noise of the storm. This flawless outcome was not the result of a lucky break. It was the execution of months of exhaustive data collection and behavioral mapping. When every variable, from human habits to mechanical delays to local drainage, is mathematically accounted for, the perfect window isn't found, it is engineered.